Hello everyone, this is Infinity Vision and my name is Rehan Nawaz. This is the second lecture on ratio. In previous lecture, we began ratio by discussing its elementary ideas. Once we were settled down with the elementary ideas, we understood and proved some of the theorems related to ratio, and then we did some problem solving to understand the whole story better. Today, we'll continue with the theory, and once we are settled down with the theory, we'll be doing some problem solving from all levels, which will help us enhance the most important aspect of learning mathematics, that is art of problem solving. So let's get started. You must be knowing how to solve linear equations in two variables. You can solve it by method of substitution, you can solve it by method of elimination, and you can solve it by method of cross multiplication. I'll quickly discuss method of substitution and method of elimination to give you the background, and then I'll discuss method of cross multiplication in a greater detail. So let's say first I'm going to solve these two equations by method of substitution. So the equations are a1x plus b1y plus c1 equals 0 and a2x plus b2y plus c2 equals 0. What I'm going to do, I'm going to write my y in terms of x from the first equation, which I can do it by transporting a1x and c1 to the right side, which will make the equation as b1y equals minus a1x minus c1, which will make the equation as y is equal to minus a1x minus c1 upon b1. Now whatever I got my y in terms of x, I am going to put that expression in the second, which I am going to substitute that y here as expression of x, which will reduce my second equation as a linear equation in x. I can easily solve my linear equation in x. Once I have solved it, I have found my x. Once I got my x, I am going to put it in my first equation to get my corresponding y. This is how we solve by method of substitution, and I am sure you are very well versed with it. The second method is the method of elimination. In method of elimination, you see the variables x and y. Now whatever variable you want to eliminate, you have to make sure that the coefficient of that variable is same. Let's say I want to eliminate y. So for eliminating y, what I need to do, I need to make sure that the coefficient of y in both the equation is same. But here the coefficient is b1 and here the coefficient is b2. So what I am going to do, I am going to multiply my first equation with b2 so that my coefficient becomes b1, b2. And I am going to multiply my second equation by b1 so that the coefficient becomes b1, b2. Once I got the same coefficient, I can subtract these two equations to eliminate that variable. So what I'm going to do, I'm going to multiply the first equation by b2, which will make the equation as b2a1x plus b2b1y plus b2c1 equals 0. And I'm going to multiply my second equation by b1a2x plus b1b2y plus b1c2 equals 0. Now I'm going to subtract these two equations, which will help me eliminate my y, and I'll be getting as the coefficient of x as a1b2 minus a2b1x, and in the constant I'll be getting plus b2c1 minus b1c2, and then I can easily solve this equation to get my x. And once I get my x, I'll follow the same procedure for eliminating x to get my corresponding y. For that, I'm going to multiply the first equation by a2 and the second equation by a1, and then I'll follow the same suit. You are very well versed with these two methods, that's why I discuss very quickly. Now we are going to discuss method of cross multiplication, which is very important and which will be giving us a lot of application in the upcoming topics. So that is why we need to master method of cross multiplication. Let's say whenever you got these two equations, a1x plus b1y plus c1 equals to 0 and a2x plus b2y plus c2 equals to 0, you have to make sure that the symmetry and the order is always written in the same way. The equation should begin with x, then y, and then constant. The second equation should begin with x, then y, then constant. Now what you are going to do, you are going to write x upon, then you are going to write y upon, then you are going to write 1 upon. What you need to write below x, what you need to write below y, and what you need to write below 1 has something to do with the structure. Now since the whole story has been written in a very symmetric order, so I'll begin with the coefficient of y first. So it would become b1, b2, then it would be C1 C2, then it would be A1 A2, and since we began with B1 B2, so I'll end it with B1 B2 as well. For the term below x, what I am going to do, I am going to cross the first two pairs, which will help me write B1 C2 minus B2 C1. This is how I am going to write the expression below x, just by cross multiplying these two first pairs. Then I am going to multiply C1 A2 and C2 A1, and I am going to write here as C1 A2 minus C2 A1. And for the last guy, I am going to write the cross as A1 B2 minus A2 B1 minus A2 B1. So this is how you solve by method of cross multiplication. Very symmetric, very structured. So now you can easily say your x is nothing but B1 C2 minus B2 C1 upon A1 B2 minus A2 B1, and your y is C1 A2 minus C2 A1 upon A1 B2 minus A2 B1. Whatever you got your x and y, you can easily verify this result by the method of substitution or by the method of elimination. But this method is going to play a big role in the upcoming topics. So you need to master this, and you need to understand whenever you are solving by cross multiplication method, you should always begin that whether it has been written in a proper order or not. Once it has been written in the proper order, you are going to follow the same routine, that x upon, y upon, and 1 upon. And for x upon, you are going to write this order, that B1 C2 and B2 C1. For second, C1 A2 and C2 A1. And for the last, A1 B2 and A2 B1. This is how you are going to solve by method of cross multiplication. Let's solve these linear equations in two variables by method of cross multiplication. The first equation is 5x minus 3y minus 1 equals 0, and the second is x plus 2y equals 12. Now first thing I need to do, I need to write both the equations in a right order, which means the first term should be of x, the second term should be of y, the third term should be of constant, and in the right hand side I should get 0. So the first equation is already in that structure, that is 5x minus 3y minus 1 equals 0. The second equation is x plus 2y, that's okay, x plus 2y. Now in the right hand side I got 12, which I am going to transport it to the left hand side, and I am going to write minus 12 is equal to 0. Now since I am going to solve these equations by method of cross multiplication, so I am going to write x upon y upon and then 1 upon. When I need to write the terms for the cross multiplication, I always begin with the coefficient of y. So it would be minus 3 and then 2. Then I will go to the right and I'll get minus 1 minus 12. Then I'll follow the cycle. It would become 5 1, and then the last guy would be minus 3 and 2. So for the first term, minus 3 into minus 12, that makes it plus 36, minus 2, that makes it 38. So I'll just write x upon 38. For the second term, minus 1 into 1, that is minus 1, minus 12 into 5, that is minus 60, which makes it plus 59. 60 minus 1, that is 59. And for the last guy, 5 into 2 is 10, minus 1 into minus 3, that is minus 3, that makes it 13. So I'll write 13 here. So what's my x? My x is 38 by 13, and my y is 59 by 13. This is how we solve linear equations in two variables by method of cross multiplication, and it was very quick. You must be seeing two equations but three unknowns. Let's say the equation is a1x plus b1y plus c1z equals 0 and a2x plus b2y plus c2z equals 0. Now definitely we cannot solve these two equations completely because you have only two equations and the number of variable is 3. But what we can do, we can write this whole thing a1x plus b1y plus c1z as a1 into x by z plus b1 into y by z plus c1 equals 0. So what I did, I just divided the first equation by z. I'm going to follow the same routine for the second. So it will become a2 into x by z plus b2 into y by z plus c2 equals 0. Now, I have reduced these two equations into something like this. Definitely, I am not able to solve all the three variables, but I have reduced it as a linear equations in two variables, where two variables are x by z and y by z. So what I can do, I can just follow the cross multiplication method and I can write x by z upon y by z upon and 1 upon. Now at the same time, you know what you are going to do. You are going to follow this routine like b1, b2, c1, c2, a1, a2, then b1, b2. So the first guy would be the first one, b1, c2 minus b2, c1. So I'm going to write b1, c2 minus b2, c1. Here I'm going to write the second guy, c1, a2, c2, a1. So it would be c1, a2 minus c2, a1. And for the last guy, it would be a1, b2 minus a2, b1. a1, b2 minus a2, b1. So we have been able to reduce this whole equations in one variable as a solution of something like this. Now what I can do, I can cross multiply by z. So I can write this whole thing as x upon b1, c2 minus b2, c1 equals y upon c1, a2 minus c2, a1 is equal to z upon a1, b2 minus a2, b1. So whenever you got the scenario that two equations and you got three unknowns and it is in the form that in the right hand side you got 0, you can break the whole story as x upon constant equals y upon constant equals z upon constant, which will help you write the whole thing as something like lambda. So what you can do, that x is lambda into b1 c2 minus b2 c1 and y is lambda into c1 a2 minus c2 a1 and z is a1 b2 minus a2 b1 into lambda, which will help you write your solution that x is to y is to z is nothing but b1 c2 minus b2 c1 is to c1 a2 minus c2 a1 is to a1 b2 minus a2 b1. So definitely we were not able to solve my xyz, but definitely I know that in what proportion they are. Let's solve this problem. Now you have to find the ratio of x is to y is to z, and you have been given two equations in xyz. So two equations and three unknown. So what I'm going to do, I'm going to write this first equation in a right order. The first term should have x, the second term should have y, and the third term should have z. So I'll begin with 7x. I'll transport 4y and 8z on the left hand side, which will make it 7x minus 4y minus 8z equals 0. In the same way, the second equation is 3z equals 12x plus 11y. So I'll begin with 12x, then I write plus 11y, and I will transpose 3z to the right side. So it will become minus 3z equals 0. Now this equation is exactly the same we discussed in the previous theory. So what I'm going to write, I'm going to write x upon, then I'm going to write y upon, then I'm going to write z upon. I'll just write the symmetry from the coefficient of y, minus 4 and 11. Then I'm going to write minus 8 and minus 3. Then I'm going to write 7, 12 and then I'm going to end it with minus 4 and 11. So the first guy would be minus 4 into minus 3, that is 12, minus minus 88, that makes it 100. For y, I am going to write minus 8 into 12, that is minus 96, and then minus 3 into 7, that is minus 21. So that will make it 21 minus 96, that is minus 75. And for z, I got 7 into 11, that is 77. And 12 into minus 4, that is minus 48. So that makes it 77, 125. So if I have to find the ratio of x is to y is to z, I'm going to say that they all are equal to some lambda. So what I can say that x is to y is to z is nothing but 100 lambda is to minus 75 lambda is to 125 lambda, which I can break it into, lambda would be cancelled and I can say 25 fours are, so I'll write 4 is to 25 threes are, so I'll write minus 3, and then 25 fives are 125. So this is the ratio of x, y, z, that is 4 is to minus 3 is to 5. Now let's look at this interesting problem. You have to eliminate x, y, z from the equations given. You have been given 3 variables and 3 equations now. The first being a1x plus b1y plus c1z equals 0. The second being a2x plus b2y plus c2z equals 0. And the third being a3x plus b3y plus c3z equals 0. What I am going to do, I am going to use these 2 equations to find my x, y and z. Once I have found my x, y, z, I'll write x, y, z in terms of lambda and substitute it here, and then I'll get rid of lambda and all the variables would be eliminated that way. So how you are going to do it? So first we are going to use a2x plus b2y plus c2z equals a3x plus b3y plus c3z equals 0. So you got x upon, then you got y upon, then you got z upon. So you're going to do b2, b3, c2, c3, a2, a3, b2, b3. So b2, c3 would be b2, c3 minus b3, c2. For y, you will get c2, a3 minus c3, a2. And for z, you will get a2, b3 minus a3, b2. Now, since you know that x, y, z has been in the same proportion, you can write lambda here. Now, what you can do that x is equal to lambda into b2, c3 minus b3, c2. Your y is lambda into c2, a3 minus c3, a2. And your z is lambda a2, b3 minus a3, b2. Now you got your x, y, z in terms of lambda and you are going to put it here in the first equation. So the first equation would become a1 into lambda into b2, c3 minus b3, c2. The second term would become b1 into lambda, and what's the y? c2, a3 minus c3, a2. And the third term would be c1 into lambda, and for z you have a2, b3 minus a3, b2. And this whole story is equal to 0. Since lambda is common to all the 3 terms, so lambda can be removed since on the right hand side you got 0. So you got something like a1 into b2, c3 minus b3, c2 plus b1 into c2, a3 minus c3, a2 plus c1 into a2, b3 minus A3 B2 equals 0. So from these three equations I have eliminated and I got this relation among A1 B1 C1, A2 B2 C2 and A3 B3 C3. Now let's look at this problem. You have got three equations and three unknown. The first two are ax plus by plus cz equals 0 and x plus y plus z equals 0. The third is bcx plus cay plus abz equals b minus c into c minus a into a minus b. Now whenever you encounter such problems, what you can do, you can find the ratio of x, y, z from the two equations, because on the right hand side you got 0. So I'm going to do the same thing. So first thing I'm going to write as x upon y upon and z upon, by the method of cross multiplication I'm going to write coefficient of y as b1, coefficient of z as c1, coefficient of x as a1 and then b1. So b minus c, so I'm going to write b minus c here. Second is c minus a, so I'm going to write c minus a, and this is a minus b, and I'm going to write this whole thing as lambda. So my x is lambda into b minus c, my y is lambda into c minus a, and my z is lambda into a minus b, right? So these two equations have made me write x, y, z in terms of lambda. Now I'm going to substitute this in this expression. So what I'll get? I'll get bc into lambda into b minus c. So because my x is lambda into b minus c, ca, y is lambda into c minus a, and this is ab lambda a minus b, which is equal to my b minus c, c minus a minus b, right? I can easily see that lambda is common here. So lambda into bc into b minus c plus ca into c minus a plus ab into a minus b, b minus c, c minus a minus b. Now the whole complex equation of three variables have been broken into a simple equation, linear equation in lambda. Now when you look into this, you can go through solving by multiplying the whole thing in the left hand side and then multiplying the whole thing on the right hand side and then comparing and getting your corresponding lambda. This is one method, but that is going to be a little longer. But when you look into this expression here, bc into b minus c, then ca into c minus a, then ab into a minus b. This is very cyclic in nature. If you look here, bc, then ca, then ab. You are getting a pair which is following a cycle, bc, ca, ab. Now whenever you get these type of expression and whenever you need to factor this expression, you should always apply the factor theorem by using the concept of symmetry. Now how you are going to apply the factor theorem? If you remember your elementary polynomial class, you must have heard this factor theorem, which means if x minus alpha is a factor of px, then p of alpha is 0, which means if you replace your x with alpha in the expression, the whole expression will become 0. If that is happening, then x minus alpha is a factor of that expression. Now here you have bc into b minus c, ca into c minus a, ab into a minus b, which means 1 degree, 1 degree, 1 degree. So basically, it's basically the product of three 1 degree terms, which means it's a cubic expression. And when you are factoring them, you need to factor them by factor theorem, which means you have to break them either as a product of three linear terms and constant, or as a product of one linear term and the quadratic expression. Whatever way you choose, by factor theorem what we can do, we see the symmetry. So if I say, if I replace b with c, I am going to replace b with c. Replacing b with c which means if the expression becomes 0, it means b minus c is a factor. B minus C is a factor. So if I replace B with C, so wherever you are seeing B, just write C in place of that. So BC will become C square and B will become C, so C minus C. In the second expression, you don't have B, so you can write CA into C minus A. In this last expression, you have AC because B has to be replaced by C, and then A minus C. Now when you look here, this is 0 because C minus C is 0. CA, AC, same guy. C minus A minus C, opposite sign. So this will cancel. So yes, I can say this expression has one of the factor as B minus C. I'll follow the same routine and I'll replace C with A. And if I replace C with A and the expression becomes 0, then it means C minus A is a factor. That means C minus A is a factor. So I need to replace my C with A. So the first term would become BA into B minus A. The second term would become A square into A minus A. And the third term would become AB into A minus B. So this is 0. BA, AB, this will cancel out each other. So again I can say yes, C minus A is my factor. Now, if I do the same thing and replace A with B, I'll replace A with B, and if the expression becomes 0, then A minus B is also a factor. So what I am going to do, the first term is again going to remain BC into B minus C, because I need to replace A with B. This will become CB into C minus B because I have replaced A with B. And the last one would become B into B, B square into B minus B. This will be cancelled because B minus B is 0. BC, CB is common. They are of opposite sign. They will cancel. So I can definitely say that A minus B is also a factor. So this was a 3-degree term and I have broken it into the 3 linear terms. But one more thing you can miss, that whenever you are breaking your 3-degree term into 3 factors, 3 linear factors, there could be one leading coefficient or a one leading factor which is a constant. To make sure that whether we got a constant or not, we just need to understand that let's say we pick one term, BC into B, that gives me B square C, that gives me B square C. If I try to create B square C, I'll multiply B with C, that makes it BC. BC with minus B square C. So instead of getting B square C, I am getting minus B square C. Let's check other. CA into A, that is C square A, minus C into C, minus C square. Again I am getting minus C square A. Here I am getting plus C square A, here I am getting minus C square A. So eventually you will notice that all the terms of this expression, and if I expand this and all the terms I'll get, they will be of opposite sign. So how am I going to balance it out? I'm going to multiply with minus 1. So I can say this whole expression can be factored into minus into B minus C into C minus A into A minus B, which is equal to B minus C into C minus A into A minus B. And by solving it, I can say lambda equals minus 1. So you must know that whenever you got a cyclic expression and by repeating it, you can easily factor them into this way, right? A very good learning point here. Now I can put my lambda as minus 1. So I will get x as minus B minus C, y as minus C minus A, and z as minus A minus B. So it was a very interesting problem. We learned quite a lot. First thing we learned that whenever you got these 3 equations, the first 2 has 0 in the coefficient as in the right hand side. So what you can do, you can write your x, y, z as a ratio form. So you can replace your x in terms of lambda. You'll substitute that in the third equation. You have broken your third equation into the linear equation form, a single variable. Now for this type of calculation, you can go through two ways. First is the long method, where you will be just opening up everything on the left hand side, then everything on the right hand side, and then you're going to divide these two expressions to get your lambda, which is going to be a very longish way. But if I see into the symmetry, this is very cyclic in nature, and I can apply my factor theorem to get this factored form, and that will help me to get lambda equals to -1. So it was a very important question where we learned a lot of complexity and how these complexity can easily be broken by the strong fundamentals.